The chosen article is called "Thermoelectric Finite Elements Analysis and Experimental Validation of Bipolar Electrosurgical Cautery" by authors Robert E. Dodge, Scott F. Miller, James D. Geiger, Albert G. C., and the person in charge of the presenting the article and who is speaking to you, Sebastián José Lito Ortegón Suárez. The problem defined in the article is based on the fact that then performing a surgery method of the cauterization now of electrocautery is implemented. This allows that when making cut in vessels or tissues, they can be closed with the help of the kit high temperatures about excessive bleeding, but when implementing this method can generate damage to the surrounding tissue where the cauterization is applied. An example of this can be seen a damage generated in a pig tissue when performing a cauterization. Due to this complication generated by the cautery disease, it is necessary to analyze the thermal distribution values on the tissues caused by the device to reduce the areas affected by the cauterization temperature, generation, modifying, and the evaluating to the type of tips for devices. The aim of this research is to better understand heat transfer in biological tissues and cauterization producers to further improve the design of bipolar surgical devices. Materials and methods. Two analyses were performed. The first one was the electrosurgical measurement of temperature in vivo, in which porcine tissues, the bipolar cauterized thermistor, and an accessory to fish the thermistor were used to perform a temperature sensor generated by cauteries. The second analysis was a finite element modeling analysis in which the COMSOL software was used to allow the designs to the tips, one FE and the other GEA, to evaluate the thermal and electrical conductivity of each, as well as generation or surface with a fairly dense mesh in contact area with the tips designated to evaluate the thermal values that the surface could receive. The first graph shows the result of tests that independent of the preserved exert of the tissues and comparing the FAM and in vivo test, showing similar values between them and reduced temperatures as it moved away from the edge of the electrode. The second graph shows the result of that depends on the pressure exerted on the tissue and compare the FAM and in vivo test. The temperature values obtained by Fn were lower, which showed that the heat transmission below must be taken into account regarding the pressure exertion. The discussion of the result was based on efficiency of the FEM analysis method for obtaining the data to evaluate two temperature data that varied in time as well as allowing to obtain temperature values transversally transversal for the diodes. The conclusion given by the author where is the study demonstrate the ability to use a FAM to study bipolar electrosurgical producers and demonstrate the importance of incorporating appropriate temperature-dependent tissue properties, electromode geometry, and compression-dependent properties in the FN model. Another delimitation of this model include is assumption of electrode tissues contact which may not be realistic in all situations. And my conclusion is that from effectiveness and the analysis with Fn of the thermal conductive is biological tissue studies can be conducted where temperature may be better focused, adding improvements to the already invented devices. Finally, the opportunity for improvement that I see is to carry out a similar investigation could be based on the deep development of a lateral cooling of the tissues system that does not interfere with electrodes of the cautery device, allowing heat conduction not to spread over a wide region of the tissue, reducing the amount of damage generated by the procedure.